And so this is going to be lesson 8.7. So using a reference table, compare how voltage in a circuit is calculated in series and parallel. So how would I connect? So if you kind of compare it on your reference table, you'll see that in series circuits, your voltage is equal to the sum of the individual voltages across each resistor. Whereas in the parallel circuit, the voltage across each resistor is the same. And then the question goes on to say, well, how would I connect three different resistors with different resistances so that they all have the same voltage or voltage drop when I connect it in series or connect it in parallel? Well, I can see from the formula itself already now that, well, if I wanted to measure voltage, if I wanted all my resistors to have the same voltage, I would connect them all in parallel, as you guys can see here. And which gets us to our next part. Now, you might have been here for the lab on Thursday and Friday, where we actually use a circuit board and had you guys use multimeters to measure voltage. Well, in Regents physics, we're kind of more specific, right? In Regents physics, we kind of say, well, is this a voltmeter? A voltmeter would be something that measures voltage, or would it be an ammeter, right? An ammeter would measure current. Now, well, how do we connect voltmeters to measure voltage properly? Well, since we know that in parallel circuits, if we connect something in parallel, we'll get the same voltage. If we connect something in parallel, that means if we want to properly measure voltage, we would connect our voltmeter in parallel, as you guys can see in this image right here, right? So let's say I have this voltmeter here. If I wanted to connect it and if I wanted to measure the voltage across the entire circuit, right? And then circuit, I would kind of put it before the light bulb and after the light bulb. And you'll see here, well, my voltage is 10 volts as the voltage is supplied by the battery. The battery is supplying 10 volts of power, or rather energy. Now, in series circuits, we know that the total voltage is equal to the sum of the individual voltages, which means that if each of these resistors are the same, right, you have the 10 ohm light bulb, two 10 ohm light bulbs, that means each of these light bulbs will have a voltage of 5 volts. Now, this is what I had you guys measure in your lab, right? So again, well, how do we measure my voltage? Well, I'll put my red probe over there, right in front of that first light bulb, and put my black probe at the end of that light bulb right there. And essentially, what I'm doing here, right? What I'm doing here is I'm connecting my voltmeter. I'm connecting my voltmeter in parallel. That's essentially what I'm doing, right? That's essentially what I'm doing. So I'm connecting this voltmeter in parallel, and this voltmeter, because it's connected in parallel, will have the same voltage as this light bulb over here. All right, so again, in a series circuit, my voltages will add up to my total voltage, and here we see that each of these resistors have a voltage of 5 volts. Now, what if we wanted to, again, here is a parallel circuit. We know that in a parallel circuit, each of these light bulbs is going to have the same voltage, right? So I'm going to connect my red probe over there. Well, it doesn't matter where you do it, right? So again, and then over there. You'll see that my voltage is 10 volts. Again, I'm connecting something in parallel. I'm adding another path for electrons to flow, and my voltage will be the same. And that's really the rule there. And so you have this practice question here. Well, which circuit diagram represents the voltmeter V connected correctly to measure the potential difference, V? Well, you want V parallel, so it's going to be the bottom right-hand choice, right? So the only choice that shows a voltmeter connected in parallel to only R2 will be the fourth bottom right choice. The first choice here, actually, let me just kind of take a screenshot, right? So this first choice here has this voltmeter connected in series, right? This voltmeter is connected in series with R2, and well, that's not what we want. We want it in parallel. This voltmeter is connected in parallel to both R1 and R2, right? So if this voltmeter measures the voltage across both of these resistors. We don't want both, we want just one. This voltmeter is connected in series, right? There's only one pathway. And really the only choice left is the fourth one. Now 2b says, well, in which electric circuit would the voltmeter read 10 volts? Right? So again, I showed you in the FET diagram, well, if we connect a voltmeter in the front of one light bulb and the end of the second light bulb, I'm measuring the total voltage across both resistors. Now, if the total voltage in the circuit is 10 volts, well, the total voltage across both resistors connected in series will also be 10 volts. So this voltmeter is connected in parallel to both of them. So my voltage there is 10 volts. And really that's the answer, right? That's the answer right there. If you take a look at the second choice, again, you see that they're connected in series, and we know that in series, my voltage is really added. So each of these resistors have a voltage of 5 volts. And so this voltmeter, because it's connected in parallel to only one resistor, the voltage that the meter reads there is just 5 volts. Choice C is kind of the same situation as choice A, but because the battery is 20 volts, the voltmeter here will read 20 volts as well. And you have a parallel circuit on choice D. So here in choice D, you actually, because the battery is 20 volts and each of these resistors are also connected in parallel, they all read 20 volts. Right? So this voltmeter also reads 20 volts because it's connected in parallel to the other parallel resistors. Now let's take a look at current. Well, how do we place ammeters or current probes, right? Because the ammeter measures current, and you'll see that in series circuits, your current is the same throughout each resistor. And so if we wanted to measure current properly, if we want to use an ammeter properly, we must place the ammeter in series with the circuit. And that's a really important point. So if I wanted to measure the current running for each of these light bulbs, or rather not each of these light bulbs because it's connected in series, but this entire circuit, I would connect an ammeter. Here. And so now I'm saying that, well, my current is 0.5 amperes. But let's say we have a circuit that's in parallel. Right? We have a parallel circuit here. I want to measure my total current. If I want to measure my total current, well, I'm going to have to put it before both resistors. And you see my current here is 2 amperes. But in a parallel circuit, you'll see that my total current is equal to my current running through resistor 1 plus my current running through resistor 2 plus etc. So if my total current in my parallel circuit is 2 amperes right here, that means each of these light bulbs should have a current of 1 ampere. Well, again, how do I measure current for each of these light bulbs? Well, I have to connect it in series. Right, so I'm going to connect this across this path. And well, what do I get? I get 1 ampere here. Right, so I have a current running through this light bulb that's 1 ampere. And the other light bulb should also be 1 ampere, so 1 plus 1 is going to give me 2 amperes. Okay? And that's how I would probably place ammeters to either measure my total current or my individual current. So again, this is something that you can just do yourself, right? 4A, how would I measure electric current? I want to measure electric current using an ammeter in series. 4B says, again, this is how to properly measure current. Let's take a look at 4C though. Let's take a look at 4C. Now 4C might be a little bit tricky to understand. So let me kind of redraw it for you, right? Or rather what it's trying to say. So here, let's say there's a current of 7 amps running through that resistor, and there's a current of 5 amps running through that resistor. Well, since this is a parallel circuit, we know that my total current is equal to I1 plus I2, right? So my total current here, right, when these electrons kind of combine back together again, they kind of, because they're in split paths, when they enter one path, well, now my total current would be 12 amps. But you'll see here that, well, 3 amps leave, right? And they want to know, well, what does this ammeter reading read? What is this current over here? Well, again, because you're splitting off into 2 paths, both of these should add up to 12. And so really the only current reading you can have here is 9 amperes. So 3 plus 9 gets you 12. So the answer is 9 amperes. Look at 4D. The diagram below represents a 3 ohm resistor connected to a 12 volt battery. Meters are correctly connected in the circuit. So what are the readings on the meters? Now, because meter Y is connected in parallel, we can kind of assume that's a voltmeter. And well, my voltmeter measures in volts. And well, the battery itself, and there's really only one resistor, we can say, well, because it's connected in parallel with the resistor and the battery, my voltage is 12 volts. And X here is connected in series, and so that's going to be your ammeter. And then the current. Well, just based on my voltage alone, I can eliminate B and C. Because Y is not 12 volts. Furthermore, Y is measured in, well, rather, voltage is measured in volts. So it can't be this. It cannot be this. Now, how do I get I? Well, I'm going to use Ohm's law. I know my resistance, which is 3. Voltage is 12, and I is I. And then when you solve for I, you should get 4. And that's the answer.